Okay, we're on the review on the radicals. We're going to be doing examples now. Again, we did cover the lecture portion. This is a tough one. It's basically the simplest radical form. And what we're looking for is that simplest radical form. We'll certainly go through examples, but I'm hoping you paid attention during this lecture. I also want to point out to students that have trouble following those lectures, those little tiny spot videos on the side that may help you, right? Now, how do you determine what helps you? You have to try a variety of ways to learn the material, including you're saying, well, maybe lecture didn't help, maybe many videos didn't help. Maybe you go to Khan Academy, look at that. Your goal, though, is to do problems that we're presenting to you, all right? So we went through this over here, and then we talked about, basically how to simplify these things and conventions, yada, yada, yada. What we need to do is start going to examples, though. So let me do another share with you. There's going to be a lot of examples here. It's going to be tedious, all right? Let me go to another share. And again, you may have to come back later in the week to look at this again when it gets posted. All right, so what I'm going to do is I'll go through it. Sometimes I do way too much writing for students. My claim over here is when you practice enough of these problems that you won't be writing a lot of stuff down. But what I'm looking for, this is a square root problem, and I'm looking for violations in it. And the first thing I notice is there's perfect squares. All right, so let me just remind you what perfect squares look like. Now, the numerical perfect squares, certainly one's perfect square, but not too concerned about that. But 2 squared would be 4. 3 squared would be 9. These are numerical. Let's see, then you got 2 squared, 3 squared, 4 squared, 16. Then you got, let's see, 2, 3, 4, 5, 25. The problem with this list, it goes on for a very long time. And I don't want to be there all day long writing them all down, but you should generate a list. Now, how about the numerical perfect squares? I'll use letters. I'll use the letter A squared. Next one would be A4. These tend to be easier because they go up by 2s, 6, and they're all going to be even. Right? I could do this for a very long time. Yada, yada, yada. So what am I looking for? I'm looking for perfect squares. So does 18 contain a numerical, excuse me, does 18 contain a numerical square factor? It does. What is that numerical square factor? 9. I hope you realize that 9 times 2 is 18. Now, so why are you leaving a big space there? Well, it's going to be more. Now, is x squared a perfect square? Of course it is. All right. Now, does y11 contain a perfect square? Well, I'm looking for an even number of factors, and that would be y10. What's left over? Y. All right, so let's make sure of this. 9 times 2 is 18. I see the x squared. Y10 times y is y11. Now, a lot of people look at the z16 and say, oh, that's perfect square, and they say z4. No. All right. It's an even number. It's z16. All right, let's go through it. Now, by the way, I realize my radical's way too big. I'm going to erase this business over here. I like to put a little hat on it. Make sure these guys don't get out. What's square root of 9? Well, what times itself would give you 9 is 3? Let's see. What times itself would give you x squared? X, because x times x is x squared. What times itself would give you y10? Y5. Why is that? Y5 times y5 is y10. What times itself would give you z16? Z8. A lot of people say z4. That's not true. Z8 times z8 is z16. What's left over? Square root of 2y. Let's look at the answer key, see if we got it. I'm looking at this, and I'm looking at this. And do they match? Yes. 3x, y5, z8, the root of 2y. All right, let's look at number 2. And there's 2 things there to look at. And what am I looking for? I'm looking for perfect cubes. And there's only numbers. So let me put the perfect cubes down for you. Now, 2 cubed would be 8. Let's see, 3 cubed would be 27. This gets tougher, doesn't it? 4 cubed would be 64. And this goes on for a very long time. All right, so I'm going to look at this now. And I'm looking at each one separately and wonder, do they contain perfect cubes? And by the way, we write problems where they're going to work for you. If you look at 54, it does contain a 27. 27 times 2 is 54. As soon as why did you choose 27? It's a perfect cube. Now, if you look at 128, it contains a perfect cube 64. 64 times what? 2. Let's put this down. What's the cube root of 27? 3. And why is that? 3 times 3 times 3 is 27. And you left off with the cube root of 2. Minus, do you know the cube root of 64? It's 4, because 4 times 4 times 4 is 64. Cube root of 2. Now, what do I notice now? I notice I have two terms that have identical radical part. All I have to do is add their numerical coefficient. And what's your numerical coefficient? 3 minus 4, which would give me minus 1. Minus 1 what? Minus 1 cube roots of 2. We generally don't like to put the minus 1 down there, but it's not wrong. So I'll just simply write minus the cube root of 2. Right, try to be neat when you're writing these things down so people can read it. And let's see. We got that one right too. Let's go to the next one. And again, they're not going to vary too much. And what are we looking for? We're looking to simplify these guys. And that's certainly a simplification of what we were given. Do they work? Of course they work. Go to number 3. And this is a perfect square problem. All right. So I'm looking for perfect squares. And let me just remind you, the perfect squares, the numerical ones anyway. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. If you were looking at the letters, I would say a squared, a4, they go up by 2, a6, yada, yada, yada. Let's look at this one at a time. I see 2. And again, we're not saying you have to be slow at this, but we want you to encourage you to think about it. 2 does not contain a perfect square factor, but x cubed does. It's x squared. What's left over? 2x. Let's go to the next one, which is 5x. Square root. Does 18 contain a perfect square factor? It does. 9 times 2x. Let's go through this one step at a time. 2. I want to point out what we're doing. We're simplifying the radical now. The square root of x squared at the math100 level, let me write this down. It's going to change when you move forward though, but don't worry about that. It's going to be x. So that's going to be x square root of 2x plus 5x. Well, the square root of 9 is 3. And what do we left over? The root of 2x. I'm going to simplify these guys. This is 2x, root 2x. This is going to be 15. Now, why is that? I'm commuting the 3 and the 5, associate them, I get 15x root 2x. I'm going to underline these two terms. They have an identical radical variable part. What I'm going to do? Add their coefficients together. What's 2 plus 15? 17. 17 what? Well, they're variable radical part. Put a box in that. Things did work out. Let's check our key and see if we got it. And we got it. All right, let's do the next one. And this is a fourth root. So I want to write down the perfect fourth for you. And I know it's tough. We're not looking for a really long list, but we are looking for a list. And let's write them down, the numerical ones first. Like, if I did 2, that's 2 times 2 times 2 times 2. That would be 16. Right? If I did 3, 3 times 3 times 3 times 3 is 81. I know it's tough. I'm just going to do 4. 4 times 4 times 4 times 4. That's 256. Now, someone could say, I need a calculator to do that. Well, use your calculator. I'm also going to write the letters down for you. A4, A8, A12. What are they doing? They're going up by 4. Well, let's look at it. And I'm going to look at each one separately. 2, fourth root. And I'm looking for a perfect fourth factor. And 162 contains the number 81. All right, what am I left off with? 2. X5 contains X4. What am I left off with? An X. Let's go to the next one. 2X, fourth root. Does 32 contain a perfect fourth? It does. It's 16. What's left over? 2x. Let's simplify this. 2 times, what's the fourth root of 81? 3. Now, why is that? 3 times 3 times 3 times 3 is 81. What's the fourth root of x4? It's x. Why is that? X times x times x times x, x4. All right. Fourth root of 2x. All right, let's keep going. 2x times, what's the fourth root of 16? 2. Now, why is that? 2 times 2 times 2 times 2 is 16. What's left over? The fourth root of 2x. Again, in time, you'll get faster at this. But right now, I'm just looking to do the problem. Equals. I'm going to simplify the first term. That's 2 times 3, which is 6. X, fourth root of 2x. I'm going to simplify the second term by doing a commutation. 2 goes with 2. That's an association now. So it's going to be 4x, fourth root of 2x. What do I notice? These two terms have identical variable and radical parts. When I say parts, of factors. I'm going to do add their coefficients. 6 plus 4 is 10. 10 what? Well, the radical variable part. Oops. Look at the key. I really mean that too. You should always look at the key. Look at the key after you've done the problem now. We're getting the same answer. All right, let's do number 5. And number 5, I want to point out we're using a simple rule. And the radical A times radical B, these are square roots, is the radical A times B. I'll write that down for you. It's going to be 21 times 6. Right, let me put this over here for you. 21 times 6 is going to be, let's see, 126, right? Okay. Someone says I'm done. You could be done. I'm not saying you're not done, but I'm still looking for that perfect square factor. And I'm looking at 126. I'm wondering, does it contain a perfect square? And certainly I'm looking at it, and I would, you might say, I think 4 goes in there. You could try 4, but 4 is not going to go into 126. I mean, it goes into 12, but then you get that 6, and 4 is not going in there a nice number of times. So what's my next perfect square? 9. Let's try 9. I know it's tough. You can use your calculator if you're struggling. Let's see, 9 from 12 is 3, right? That's 14. So I'm going to write that down now. So I'm going to say 126 is really 9 times 14. Well, what's square root of 9 is 3. What do you get? Root 14. Box in this, look at my key, and write it down. I want to do this one other way, and don't feel obligated to do it in 2 ways. Do it the way you're comfortable doing it. I'm going to write down this as a different way of doing the problem, but you decide how you want to do them. What I would do is I would just break the numbers down because they're simpler. What's root 21? It's actually root 3 times root 7. What's root 6? Root 3 times root 2. Let me put on what I just did over here. I took this, I broke it into this. I took this, I broke it into this. Then I do a commutation. Root 3 times root 3 is 3. All right, what I'm doing. I'm doing these two here. Root 3 times root 3 to a commutation is just 3. Root 7 times root 2 through a commutation is root 14. Do we get the same answer? Of course we do. All right, let's go to the next one. I want to go through that with you, and I'm just going to do the multiplication. As I do that, I get something. 3 times 21, 63. All right, x7 times x7 is x14. Y times y6 is y7. I'm going to look for perfect squares now. Use the square root problem. 63 contains a 9. 9 times 7, right, is 63. 9 is a perfect square. X14 is a perfect square. Y7 contains a perfect square. It's Y6. 9 times 7, 63, x 14, y 6 times y is y 7. Let's write this down. What's the square root of 9? 3. What's the square root of x 14? X 7. Why is that? X 7 times x 7 is x 14. What some students do, though, is they take the index, which is 2, and divide it into this number, which is 7. They take the index, which is 2, divide it into that number, and they would say y3. Whatever works for you. I'm going to say y3 times y3 is y6, though. And what's left over? This. Look at the key. Make sure you're staring at that. And you do factor by factor. 3, x7, y3, the root of 7y. All right, let's go to 7. Well, it looks nasty. But I still want to do it. And again, there's a variety of ways of doing it. I don't want to confuse you with all the different ways. I'm just going to multiply it. What's 4 times 8? 32. X squared times x, x cubed. Y squared times y12, y14. All right, let's take a look at it. I'm looking for cube roots now, right? So what's the largest perfect cube contained in 32? Well, let's see, 2 times 2 times 2, that's 8, right? So 8's in 32. Now, I'm going to put that down for you. So I can put cube root 8, and there's going to be times 4 now, right? 8 times 4 is 32. X cubed is a perfect cube. And let's see, what's the largest perfect cube in A14? Let me write perfect cubes down for you. A cubed, they go up by 3, right? A6, A9, A12, A15. So I can say the biggest one would be Y12. All right, Y12. What's left over? Y squared. Let's do it. What's cube root of 8? 2. Cube root of x cubed is x. I want to point out what some students do. They take this exponent and divide it through. It'll be 1. What would this one be then? Well, 3 into 12 goes 4 times. We'll look at the key later. And what are you left off with? The cube root of 4y. By the way, I realize that not looking too good there. I'm going to erase it and write a better looking number there. That was a 2. Y squared. All right, put my box on it and check it. I'm checking this, checking this. Do I get it right? 2xy4 cube root of 4y squared. Looks great. Let's do this one over here. This is a distributive property now. What I mean by that, this 35 gets distributed across these two terms. Let's do it one at a time now. So what do you get? The root 35 times root 35 minus root 35 times 5. Well, I don't really feel like doing the multiplication, but I'll write this down. What's this going to be? 35 squared. I'm going to write this one down. It might look strange to you, but I'm going to write down 35 is 5 times 7 times 5. All right, let me repeat what I just did over there. I looked at this. I said 5 times 7. So why'd you have done that? I'm seeing the perfect squares now. Let's write this down. Square root of 35 squared is 35 minus, well, that's 5 squared, right? What's square root of 5 squared? 5 root 7. Look at the key. All right, let me stop at my advertisement now. For some students, this goes so fast, it might as well be going to speed of light. And that happens. Not everyone's at the same speed. So what I do in the notes is I put little embedded videos in it for you. So you could watch me do this problem again. Now, by the way, I might do it slightly different when I'm doing this little video over here because this is lecture portion. But the bottom line is, you know what? You may have to come back and look at this later. You may have to study, right? And that's important. If you want to learn the material, you may have to put in a lot of extra time to learn the material. And we're hoping to get there. However, if for whatever reason you still can't get it after all your work, come by during office hours and we can help you through the material. All right, we're here to help. All right, let me go to number 9 now. I'm looking at it and it's distributive property. And I'm going to write it down one step at a time. 3 times 3 is 9. 3 times 2 root 5 is 3 times 2 is 6 root 5. Then it's going to be minus 6 root 5. Because, minus 2 times 3 is minus 6. And then I get minus 4, because minus 2 times 2 is minus 4, root 25, because 5 times 5 is 25. Let me see if I can do this. This is 9. This is nice. They disappear. These are what's known as conjugates. What's a conjugate? A plus B, A minus B. And they really simplify nicely. It's A squared minus B squared. You may want to give that some thought. All right. Let's go to the last term. What's the last term going to be? Minus 4 times, what's square root of 25? 5. Let's keep going. 9 minus 20, which is minus 11. Let's look at the key, see if they got that answer. And they did. All right, let's do number 10. This is a squaring problem. I'm going to write down twice and use the distributive property of multiplication. Whoops, I made a mistake. Okay. A lot of people look at this and say, I would never have done that. I just want to write the answer down. And what happens when they actually write a wrong answer down? And you should be very concerned when you say something that's not true. And certainly you don't want to keep doing that over and over again. I'm going to use distributive property multiplication, but again, now I'm going to say in time, maybe you can write the answer down without doing work, but I don't think we're at that level yet. Let's do the multiplication. What do you get? 1 minus 3 root 2. Someone says, what'd you just do? I distribute the 1 across those two terms. Now, what am I going to do? I'm going to distribute this across these two terms, one at a time. And what do you get? Minus 3 root 2. Now, minus 3 times minus 3 is plus 9, and root 2 times root 2 is 4. Let's keep going. You get 1. That was easy. The two middle terms, they don't cancel. They combine. Where they combine to? Minus 6 root 2. And last but not least, what do you get? 9 times 2. Let's keep going. 1 minus 6 root 2 plus 18. I can add 18 and 1 together, get 19 minus 6 root 2. Now here's the deal. I got to be honest with you. Some students can look at that and write the correct answer down. Most students can't. Please do the work. Let's check, see if we got the right answer, though. We got the right answer. Let's go to number 11. Pull us back. We're going to number 11. And it's another, basically it's a repetition problem, right? Repetition is one way to learn the material. 5 times 3 is 15. Minus 10 root 2. Don't be intimidated. Plus 9 root 2. I'm using the distributive property of multiplication. Minus 6. Well, root 2 times root 2 is root 4, and root 4 is going to be 2. Let's keep going. 15. I'm going to combine the two middle terms, would be minus 1 root 2, and 6 times 2 is 12. 15 minus 12 is 3, so it's 3 minus root 2. Look at the key, make sure you can do that. Let me repeat this. For some students, that goes so fast, they couldn't have even copied that down at that speed. All right? You need to go back, look at the material again. But right now, I'd say try to pay attention, try to follow. Even if you can't copy what I'm doing, try to follow. You can always come back and watch the videos again. You can always come back and do that. All right? Let's do number 12. And I wanted to use the distributive property of multiplication. 1 times 1 is 1. By the way, these are conjugates. Let's not worry about that, though. 1 times 1 is 1, and then we get root x, because 1 times root x, root x. Then we get minus root x. Then what do we get? We get minus the root of x squared, which in math 1 level is just x. What happens here? The two middle terms disappear. This is what's so nice about conjugates. What are conjugates? A minus b, a plus b. They work out rather nicely. A squared minus b squared. What do you get over here? 1 minus x. Let's look at the key. I'm seeing it. All right, number 13. It looks bad. All right, now someone's y's look bad. We really do not like to have as a denominator anything except for something that's considered whole. And the root of 3 is not considered whole. So the way I'm going to take care of this is to multiply the top and the bottom by the root of 3. And what do you get on top? Root 21. And what do you get on bottom? Well, root 3 times root 3 is root 9, and root 9 is 3. All right, look at the key. Now, what I'm claiming over here is that the square root of 21 over 3 is identical to root 7 over root 3. Let me remind you why this is not good. We want the bottom to be a whole number, all right? Now, if you went back and read the notes or listened while we're giving lecture, it says that we can't have a radical in denominator. And why is that? We want whole numbers, all right? So we're doing okay. Let's look at number 14. Again, if you're not thinking, you could easily write down a wrong answer very quickly. We're not interested. So there's a radical in the bottom. And what I'm going to claim over here is I need to multiply by something to get rid of that to make it whole. So what would I multiply? By a cube root of something. But now someone says, if you multiply the bottom by a cube root of something, you need to multiply the top by the cube root of something. Well, I'm looking to make it a perfect cube. I realize some students want to say 2 because we just did that with the prior problem, but it's not 2. And why is that? 2 times 2 is 4, and 4 is not a perfect cube. What's the first perfect cube I could hit? 8. So it's going to be 4. Let's go through the arithmetic. The top would be the cube root of 4. And the bottom would be the cube root of, well, 4 times 2 is 8. And the cube root of 8 is 2. We're done. We got the bottom to be whole. Look at the key. Make sure you're staring at that. All right, let's go to 15. I know this is tough. You have to take a break. Oops. Well, I got a problem again. The bottom's not whole. So what am I going to do? Try to make it whole. Get rid of that radical. It's a square root problem. So I'm going to multiply the top and the bottom by a root of something. Well, what times 3 would make it perfect? 3. 3 times 3 is 9. It's perfect square. What times x would make it a perfect square? X, because x times x squared. Let's go through the work. The top will be 2, square root or the root of 3x. The bottom is going to be the square root of 9x squared. Well, let's write this down. 2 root 3x. What's on bottom? Well, the square root of 9 is 3. And the square root of x squared at mathematical level is just x. All right. Let me look at my clock. Yeah, I guess this is long. I know that. Let's look at the key. Again, we can't have radicals in the denominator. All right, this one, it's got troubles. It's got a lot of troubles. What I'm going to claim over here is that I'm going to rewrite it. And so I'm not going to say it's going to work for you, but this looks like it has so much troubles. I want to see if I can rewriting it fixes some of the troubles. And I think it does. And what would I get over there? I could reduce it now. And what would I reduce? 48 divided by 12 is just 4. And x squared divided by x is just x. So I'm going to say by, really simple process, and I'll tell you what I did over here. The root of a over root of b is the same thing as root a over root b. All right, conditionally. So we're not worried about the condition so much. So what I claim over here, this is much easier for me to do the problem now. What it's going to be, square root of 4 is 2, and I get root x. Let's look at the key, see how we did. Wow, that's good. All right, let's go to number 15. And again, I'm looking at it, and I need to get a perfect cube now. Multiply by the perfect cube, multiply the top by a perfect cube. Well, I'm looking at 25, and the perfect cube related has 125. So I'm going to say 5. Again, you'd have to have some sense of numbers to know that. But let me write this down for you. This will be 15 cube root of 5. That's the top. What do you get on bottom? The cube root. Well, let's see. 5 times 125. I'm sorry. 5 times 25 is 125. What's cube root of 125? 5. And why is that? 5 times 5 times 5 is 125. What do you get on top? 15 cube root of 5. All right, what am I going to do now? I'm going to reduce. 5 goes into 5 once, goes into 15 3 times. So what are we left off with? Pretty simple. 3 cube root of 5. Again, I know it's a lot to you. Mistakes happen. Please check the answer key to make sure you can agree with that. All right, let me do number 18. Very similar. What I'm going to do is I'm going to write it as one single fraction. What would you get? 15 x squared y4 75 x7 y cubed. I'm going to keep reducing it if I can. And I'm looking at it and I'm seeing it really doesn't look that bad to me. I mean, 15 over 75, right? Let's see, what would that give me? I guess it'd be 1/5, right? Right? 5 times 15 is 50 and 25, 75. Then I'd get x5. That's not so bad, right? And you get y on top. All right. I'm going to do something that some students, oh, this is too tricky for me to follow, but I want to make the bottom a perfect square. All right. So let me see if I can do that without doing too much more work. Let me make that bottom a perfect square. Let me see if I can do that. Well, what times 5 would make it a perfect square? 5. 5 times 5 is 25, right? Now someone says, why do you want to do that? I want to take the square root of the bottom. I don't want the bottom to be a radical. And what times x5 would make it a perfect square? Remember, they have to be even numbers, right? So now the x, make it x6. All right, let's write that down for you. So what do you get? On top, you get the root of 5xy. On bottom, you get the root of 25x6. Well, I can definitely do the bottom, right? What's the root of 25? 5. What's the root of x6? x3. By the way, that's not the only way to do the problem, but it's one way to do it. If you need alternative methods, I would say search around the internet for those. Like go to Khan Academy, whatever. You might see some variations on this. However, what you will not see is a variation on the answer. The answer is always going to be the same. Now, granted, at this level, certainly if you get higher levels, they start using absolute value symbols for some of these problems. But I'm not worried about that at this point. I'm worried about this stage. Right? Did I get the same answer? Of course I did. All right, number 19, a little more of a challenge. There's a radical in the bottom. And certainly we're hoping you remembered that we had to do something about conjugates. And what's conjugate of 2 minus root 3? It would be 2 plus root 3. Now, someone says, why are you going to do that? It's going to get rid of the radical in the bottom. Let's do the top first, pretty simple. And again, we'll go in stages. 3 times 2 is 6, plus 3 times root 3 is 3 times root 3. Do the bottom. 2 times 2 is 4, plus 2 root 3, minus 2 root 3. I'm using the distributive property multiplication, minus root 9, which is minus 3. Let's keep doing it one step at a time. What do you get on top? 6 plus 3 root 3s. What do you get on bottom? Well, something nice happens. And that's what's the deal about conjugates. Nice things happen. What's 4 minus 3 is 1. What do you get over here? 6 plus 3 root 3. All right, please go to the next page and look at the answer. And we're looking for 6 plus 3 root 3s. And we're seeing it. It's right here. Okay, so I realize for some students that just, it went way too fast for them. You're going to have to study. That's what we're trying to encourage you guys to do, study. How much study? As much as you need to learn the material. I'm going to say, roughly speaking, you spend about 10 hours a week studying the material. All right, so what I want to get across to you is that after you study, you got to say something. I wonder, can I do these problems? Can I do this and get this? Can I do this and get the answer? Can I do this and get their answer? Can I do number 4 and get their answer? I don't know. You have to try. And that's what we want you to do. We want you to try. After you try in your study, you can't get it, come by for help, and we'll be more than happy to help you. And I really mean that. We'll be more than happy to help you. All right. Thanks for paying attention. See you next time.